Yes, now it has started. Okay, sharing my screen. I hope you are all able to see my screen. Today, we are going to touch upon and start learning about my favorite topic in data center technologies, which is data protection. Okay. And these are the high level concepts that we are going to learn about data availability, data protection, little bit about data security, then data governance, risk and compliance. Okay. Why this is my favorite topic, I'll tell you. Many people think that if you spend more money on a hardware or a software, that should work absolutely fine without any glitches. Okay. But they don't realize that in spite of doing, all kinds of quality checks at factory, so on and so forth, still, hardware is susceptible to failure and you cannot predict which hardware will fail when. Okay, it's not possible to predict. Okay, yes, you can get some indications on when it may go bad eventually, but exact point of time when something will go bad, you cannot predict. Okay, and this forms the basic assumption or foundation of all other technologies that are built to protect the data that is residing in server storage and all aspects or all components of a data center. Okay. So what do we see here as an example? The lady here says that they need to have the entire environment as a highly secure one because they are storing sensitive information. Maybe it is related to finance or maybe it is related to defense. They also have to see that they are not violating any data privacy laws. Like in European Union and in US, okay, there are privacy laws. In European Union, it is called as GDPR, okay, General Data Privacy Regulation. In India, India has recently launched as a part of its IT Act called DPDP, okay, Data Privacy and Digital Protection Act, okay. This Act of India was supposed to be launched a few years back, but there were so many iterations it went through, and now the act is in force. Okay. So any company which is storing data have to also make sure that apart from protecting their data, they also have to make sure that they are not violating any of these government rules or regulations. Okay. And we will see at a high level concept, okay, how this is done. And hence the need for this lady, okay, is to have a storage solution that guarantees maximum security, helps in recovering the data whenever there is a cyber attack without impacting services. Now that's an ideal world without impacting services, but definitely when there is a cyber attack, when a disaster happens, or when there are failures, there will be an impact. Okay, it is not possible not to have an impact. Okay, if you want to design such a solution where not even a single byte of data will get lost in time of a disaster or in time of a failure, then you will have to pay significantly higher to build such a solution. Okay, extremely high cost to build such a solution. So let us see what are the concepts involved in setting up such a solution for a customer and what is the role of each of these solutions in the data center. Okay, that is what we are going to learn now. So first thing that we have to learn is data availability, and Under data availability, basically what the expectation of the customer is that whatever failure happens in the system, the data needs to be available. That means whenever the user or the application is requesting for a data, the storage system cannot deny saying that, oh, I cannot give you the data now because of so and so reason. No, that is not acceptable. Okay. Always the system should respond saying that here is your data. That is the expectation. Okay. All right. Now, that is called as building resiliency or redundancy. Okay. Now, in a few of our earlier classes, we understood that we can build n plus one redundancy in components inside the storage system. And we spoke about the storage controller being redundant to each other, right? If one storage controller fails, still the other storage controller can take over the operations of the complete storage system and serve the read and write requests coming from the users or applications. But what if other components fail? How are we going to set up the resiliency for that so that there is no impact both in terms of business operations and also financial impact? Okay. So what kind of design we need to develop? What kind of architecture is already present inside storage systems and uh, servers to do this? Okay. So we are going to learn some of these concepts. They are called as high availability concepts. They are called as data protection concept, data availability, data redundancy. All of that boil down to the same set of things, okay, which is how to protect your data and make sure that this data is available for read and write purposes, irrespective of the failures that can happen inside the components, both at the hardware level and at the software level. Okay, so we will identify each of the components that can fail and how it is, set up. Okay, and then the next level of data availability is data protection in terms of how to make the data available in another place when the complete data center is gone. Okay, and this is called as business continuity or disaster recovery. We learned a little bit about this. Okay, and the focus of this data protection is to make sure that your data is retrievable and recoverable in the quickest possible manner, okay, from the last known good copy. Now, before we go into this discussion of RPO and RTO, I want to discuss something else with you, okay? And one second, let me open the browser. Hmm. So, I have a question for you all. We understood the various components inside a storage system, right? I want you to tell me in that entire storage system, okay, what we have understood, which all components can fail? Can you all put in the chat? In the storage system that we identified various components, right? We identified that we can have uh, the storage controller. In the storage control, we have front end ports, then we have the cache, then we have the back end, then we have the backend ports, then we have multiple daisy chain connectivities to the multiple disk drives, and then we have the disk drives themselves, either HDD or SSD, right? So tell me, which all components can fail in this entire stack of things? No, no components can fail. Prakash, that's not the right answer, Prakash. Any component can fail. Yes, all components may fail to some extent. True, true. That is the correct answer. See, each and every component of the storage system is susceptible to failure. Okay. Now, yes, Anand, understood, Prakash. Anand, you're typing something. Go ahead. So, power supply, yes, power supply can fail. And that is why we will see that behind the chassis of a server or of a disk shelf or a controller shelf, okay, you will see that the power supplies are actually field replaceable units. Of course, there will be multiple power supplies. Each power supply you can actually pull out and put in a new one. Okay. Unlike our desktop or laptop, where you cannot take out the power supply, right? It is like hardwired into the system, right? But in the case of a data center appliance, a data center equipment like a server or a storage, each of the chassis will have power supplies that are removable, okay, and they can be replaced on the fly. So that is one redundancy that we can build in. What else? Okay, see, just imagine this. When you have a bunch of electrical and electronic components, okay, along with a few mechanical components inside the storage system, okay, which one do you think has the higher chance of failure? Is it the electrical or electronic components, or is it the components having the mechanical parts in it? Very simple. Yes,
Mechanical.
Hari. Mechanical. Yes, correct. Any part or any component that has mechanical aspects, okay, they are susceptible to higher failure rates. Okay. And here we introduce a term called MTBF. Okay, MTBF. I'm putting in the chat. MTBF, where MTBF stands for mean time between failures. Okay, mean time between failures. So every hard disk manufacturer, okay, has to publish their MTBF value or their MTBF number, and it will be measured in various ways. Uh, Generally, MTBF for hard disks is based on number of months or number of years of operation, because hard disk once plugged into a storage system will never be shut down. It will be constantly running, okay, 24/7. Whereas in SSDs there are no moving parts, but every read or write operation to the SSD solid state drive will have a charge or a discharge effect on those small transistors inside, right? So in SSDs, the failures are measured, or MTBF is measured in terms of how many million input output operations can it sustain. Okay, how many million IOPS, it's called IOPS, input output operations per second. Okay, now again, the SSD manufacturers have to publish this value. Okay, so in their labs, in their testing labs, in their factories, they will do all kinds of tests to understand this. Okay, and they'll have to publish these numbers. Okay, now why am I talking about this so much? Okay, because all the technologies that we are going to learn now will have the basic assumption that these hard disks and SSDs are going to fail eventually. Okay, these hard disks and SSDs are definitely going to fail. Okay, so what are the mechanisms that are available in the storage system to overcome these failures? First of the hard disks, and then of the all the other components that are forming the complete storage system. Okay, so that is what we are going to understand today. And the most important concept in protecting the data that is there inside a hard disk or SSD is called as RAID. 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 I'm putting in the chat. RAID. RAID. Okay. Can anybody tell me what RAID stands for? What does the acronym RAID stand for? I put it in the chat. Have a look. Redundant array of independent or inexpensive disks. That is what is RAID. So read the word very carefully. Read the acronym very carefully. Redundant. Redundant means what? It's not just one. Okay. RAID is not meant for a single hard disk or a single SSD. Okay. Whenever we are talking about this concept called RAID, we are actually talking about a bunch of hard disks or a bunch of SSDs. Okay. We're not talking about a single one. And it says it's an array. What does an array mean? An array means a structure. Okay. A predefined structure. Okay. Which means whenever we are applying RAID on disks, either hard disks or SSDs, we have to identify what kind of RAID we have to apply, and each RAID has its advantages and disadvantages. Okay, and we are that is what we are going to learn today. Okay, what exactly is RAID, and what are the different RAID types available, and what are the advantages and disadvantages of each of these RAID types. Okay, now this is absolutely critical concept. If you have understood how RAID works, okay, you would have mastered the basic level of storage systems. Okay, in your life you do not have to worry about this again. It's like learning how to cycle or how to swim. Okay, if you have understood RAID very well, then your basic or foundation level understanding of storage systems is like cemented. Okay, you don't have to come back to it again. Right, now let me share my screen and let me show you some animated videos of what exactly is RAID and how RAID is used to deal with hard disk failures. Okay, so here some types are there, and yeah, let us go for this one. Raise. Okay, now same information is available in wiki also, and I will also show you a wiki. Okay, so as I said, RAID stands for redundant array of independent disks. Okay, and we are talking about multiple disks at the same time. Okay, you we saw that in a storage system it's not a single disk that is getting populated, right? There are multiple types of disks that are getting populated in uh, a storage system or inside a server. So these are the various RAID types, okay, that are used for basically two purposes. What are these two purposes? First purpose is fault tolerance. Okay, first purpose is fault tolerance, like as you see here. Okay, and second purpose is redundancy. Even if a disk fails inside a group of hard disk, still users should be able to read and write data to it. Then comes performance. See, when you have multiple hard disks which are serving data, we should be able to create a mechanism using which all of them are working together, so that when they are working together, I can read and write more amount of data parallelly to them at the same time. Okay. And that is why one of the advantages also that you get out of RAID is increased performance. Not always, not in all RAID types. Okay. But there are certain RAID types where you can get increased speed. I mean, when I say increased speed, whatever speed you would have got from operating a single hard disk versus whatever speed you will get by operating a bunch of hard disks together, obviously that will be higher. Adding them together will be higher. Okay. So the basic need for having RAID is these three things: redundancy, fault tolerance, and in some cases, increased speed. And this is the reason why the industry came out with various RAID configurations. Every RAID configuration has its advantages, disadvantages, it has its limits. Okay, so we will understand what those limits are and how actually RAID happens. So, moving forward, this is what RAID stands for. Some people say independent, some say inexpensive. Both mean the same. And in a RAID, we are actually working in parallel with multiple hard disks or SSDs at the same time. And there are different RAID levels, and each optimized for a specific situation or a specific purpose. Okay. And this is basically, they are unique. In a single set of hard disks, you cannot have multiple types of RAID, but in a single storage system, you can have few hard disks with certain RAID level and few hard disks with another RAID level. That is possible. Okay. But the same hard disk cannot participate simultaneously in multiple RAID configurations. So you have to understand that very carefully. Okay. When you are applying a RAID on a particular hard disk, that hard disk can work only with that RAID configuration. The same hard disk cannot work with multiple RAID configurations. Okay. But when you are working in a larger system, okay, with hundreds of hard disks, okay, a few hard disks can be in a different RAID, and other hard disks can be in a different RAID. That is possible. But when you're talking about a single hard disk, okay, that single hard disk cannot participate or be part of multiple RAIDs at the same time. Okay, so this you have to understand. Now, these are the different RAID levels: RAID 0, RAID 1, RAID 5. Okay, then we have RAID 6. Okay, then I think the latest one is RAID 7. I'm not sure this video will have that. RAID 10, of course. Now, let us understand some of the different words that are being told here. We are seeing basically three different words coming up whenever we are discussing about RAID. Okay. First word that is coming up is striping. Second word that is coming up is mirroring. And third word that is coming up is parity. Okay. So first, let us understand what these words are. What do they mean? Okay. Then you will be able to easily understand what is RAID 0 and what is RAID 1 and the other types of RAIDs. Okay. So what is meant by striping? So basically, striping means cutting. Okay, striping means cutting, and while cutting, pasting it to multiple hard disks at the same time. That is what is called striping. Okay, so if I have to give you a more practical analogy, let us say that it's your birthday. Okay, and whenever we were in school, we used to distribute chocolates to our classmates, right? In order to do that, you had to go to a store, you had to buy a bunch or a bag of chocolates, and after you come to school, you're distributing those chocolates equally amongst the people to whom you want to share your birthday with, right? That's what you're doing. So just imagine that bunch of chocolates or that packet of chocolates to be one full data that needs to be written to the hard disks. Okay. Now, instead of like how we do in a laptop or a desktop computer, when we have a single hard disk, what are we doing? We are writing that bunch of chocolates or bunch of data to a single hard disk. Okay. So there is no concept of RAID. There is no concept of striping. Okay. But when we have multiple hard disks, when we have more friends, okay, instead of having just a single friend, that same bunch of chocolates we are distributing equally to all the friends, okay, at the same time. Okay. Similarly, this data packet or this bunch of data, whenever we are doing something called as striping, we are cutting it into equal parts, and that equal parts we are parallelly distributing and writing to multiple hard disks at the same time. Okay, that's basically called striping. Okay, which means you are operating, which means you are writing first and then reading from multiple hard disks at the same time. Okay, so what do you think are some of the advantages that we can get out of doing this concept called striping? Hope you have understood what striping is. Anybody who hasn't understood what striping is? Okay, so anybody can tell me what could be some of the advantages of striping? Come on, it's not so difficult. Any answer, please.
Increase in performance.
Excellent. Who was that?
Anand.
Anand. Yes, very good. Increase in performance. Why Anand? Why increase in performance?
Because the information will be distributed parallelly and equally between the storages, sir.
Yes, yes.
Hence, it will increase the speed.
Absolutely right. That is very good. Very good. So what Anand said is absolutely right. Striping increases performance. Okay. Because you're parallelly writing and reading from bunch of hard disks at the same time. Okay. And that exactly is what RAID 0 does. As you can see here, the RAID 0 configuration is used for striping. Okay. And nothing else though. Okay. So, which means RAID 0 does not give you redundancy. It does not give you fault tolerance. It gives you only one advantage, which is striping and hence increased performance. That's it. Okay. It does not give any other advantage to you. It only gives you one performance, one advantage, which is increased performance. That's it. Okay. Now we come to the next kind of a RAID, which is called as mirroring. What is mirroring? It's there in the name itself. Okay. Whatever we do on one, we have to do on the other. Okay. Whatever we write to one portion of the one hard disk, exactly the same thing we have to write to the second another hard disk, maybe somewhere else. Okay, so that is called as mirroring. So what is happening is, let me take the same example. Your birthday, bunch of chocolates, okay? Now you have two sections to distribute to. So what you'll do, you'll exactly cut it into half, okay? And one half of the chocolates you will equally distribute in section one. And at the same time, the second half of the chocolates you will distribute to the second section, okay? Equally, okay? So that is exactly called mirroring. When we are taking a bunch of data, first you divide it into half. One, while you are writing the first half to first hard disk, at the same time, the second half you have to write to the second hard disk. Okay. And whatever is being on the written on the first hard disk, the same thing is getting written on the second hard disk also. Exact copy. Okay. It's just a copy paste, but happening parallelly. Okay. So that's called mirroring. All right. Now, what do you think are the advantages of mirroring? Anyone?
We'll have the two copies of data so that we can back up.
Yes, correct. Who was this? Hari? Prakash?
Yes, Hari.
Hari? Okay, Hari, absolutely right. So, mirroring is giving you the advantage of fault tolerance and redundancy because you're keeping an exact copy of your data on another hard disk. Okay, even if the first hard disk fails, your complete data is there in the second hard disk, right? So, even if the first hard disk fails or even if the second hard disk fails, you are still not losing your data. But is that true with RAID 0 when you're doing striping?
No, sir.
Yes. So in when we are doing RAID 0 only, okay, if you are doing striping only, if a hard disk fails, you cannot recover that data back. It's gone. Okay. So you're getting better performance, but you're not getting fault tolerance or redundancy. But when you come to RAID 1, you're getting fault tolerance and you're getting redundancy. But are you getting performance? You're actually degrading performance. Why? Earlier, that single amount of data had to be written to only one hard disk. But now the same amount of data has to be written twice to this hard disk once and the other hard disk once. So the number of writes that are happening to the hard disk layer is doubling. So your performance is coming down actually. So that's why in IT, in the entire IT world, the moment you get an advantage, there will be a disadvantage to it, and we need to understand. So in RAID 1, the advantage that we are getting is fault tolerance and redundancy. But what we are losing performance. Okay. These were the first two RAID types that came into existence way back. Okay. In 1980s, sometime in 1980s. That is when all the engineers and scientists came together and said, why don't we combine these two RAIDs and create a RAID where we get best of both worlds? Okay. That is where the last RAID that you see, RAID 10 or RAID 10, it's called. Some people also call it RAID 01. Okay. Doesn't matter. Ultimately, all of them are same. Okay. We are combining mirroring and striping. Okay. That means not only are we writing the data parallelly to multiple hard disks, but for every write that we are doing to one hard disk, we are copying the same to another hard disk. Okay. So we are striping and mirroring at the same time. So we are getting the dual advantage of whatever is the performance advantage of RAID 0 and whatever is the redundancy advantage of RAID 1. Okay. Now, before I go any further, I would like to ask you a few questions only on these three RAIDs, RAID 0, RAID 1 and RAID 10. Okay. What do you think is the minimum number of hard disks required for configuring RAID 0? We all know that it cannot be 1. Okay. It has to be greater than 1. So can you all tell me what is the minimum number of hard disks required to configure RAID 0?
Two, sir.
2. Okay. Correct answer. What is the minimum number of hard disk required for RAID 1?
For that also two, sir, because we need
Perfect.
to
Yes.
mirror them.
Correct. 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 Absolutely right. So minimum number of hard disks for RAID 0 is 2. Similarly, minimum number of hard disks required for RAID 1 is also 2. Okay. But now, when we come to RAID 10, what do you think are the minimum number of hard disks required to implement RAID 10?
More than two.
Yes, but how many? See, it's there in front of you only. Just apply your thinking a little bit. You
Two,
need
sir.
two. You need
Means
two
for
for RAID 0. Yes, somebody said another answer. What was it?
maybe it's three because
Mm-hmm.
if one
No, no. Somebody said. Who said 4? Somebody said 4. Okay, 4 is the right answer. That's the minimum. See, the basic common sense. You need 2 for striping, and for these two, you need another 2, no, for mirroring. Whatever is written on the first disk has to be written on the third, and whatever is written on the second has to be written on the fourth. Simple. So you need at least 4 drives to configure RAID 10. Very simple. Okay, that is how you create a combination of mirroring and striping. Now tell me, if RAID 10 has the advantages of both RAID 0 and RAID 1, okay, what would be the disadvantage? What could be the disadvantage of RAID 10?
Maybe cost effective.
Yes, it is not cost effective, okay, because you have to spend double. You have to
Double.
buy twice the number of hard disks that you want to get this advantage, right? So, cost is the disadvantage with RAID 10. And because of that reason only, okay, RAID 5 and RAID 6, and in recent terms, recent days, more number of RAIDs have come, okay, which is called parity based RAID. Okay, it's called parity based RAID. Now, what exactly is parity? I will tell you. Okay, so let us just go through this video. Then, once you see the animation, you will be able to understand, okay, that what exactly is parity and why it is advantageous. So, here we are seeing an animation of RAID 0. As we understood, RAID 0 is just for striping. Whatever is your data, okay, it will get equally distributed into 2 drives. Minimum number of drives for RAID 0 is 2, and by using multiple disks, see, at least 2 at the same time, okay, and we can have multiples of 2. This offers high performance because you're striping the data and writing and reading parallelly to both of them, and both these drives are like interconnected to each other. Okay, so this is RAID 0, right? Now you get 2 drives, double the read and double the write performance. Okay, this is the advantage. What is the disadvantage? If one of the drives undergoes a hardware failure, then that's a data loss situation. Okay, all the data that was stored on both the drives is lost because you have striped it, no? So half of the data is elsewhere. So using the other half, you cannot reconstruct the data. Okay, and how we are going to overcome this? If somebody is using RAID 0, you have to take very frequent backups and keep the data, a copy of the data elsewhere. Okay, and we learn about backup technology later. Okay, and we'll go depths into it. So this is the way we are going to overcome this. Okay, so you get most extreme performance possible, and you can apply it on SSDs also, But if one fails, then you will be this one lost. And see the use cases. Wherever extreme performance is required, it is advisable to have striped data. Okay, but nobody uses RAID 0 today. We'll see why. We have better mechanisms actually. Yeah, so we will understand what is this overhead caused by parity once we understand what exactly is parity. And most of the storage capacity is used after formatting because there are no overheads. And it is very easy to implement and maintain. That is also true. Okay. No fault tolerance in RAID 0. If you lose a hard disk, then the data is lost. So it should not be used for mission critical systems. Now we talk about RAID 1. RAID 1 is what? Mirroring. Whatever you write to one disk, the same you will write to the second disk also. Okay. One is called as the data drive, second is called as the mirror drive. So even if one data drive fails, you will get the complete data from the other drive. Okay. So there will be no data loss, but there is no performance also. Okay. You will get only performance of one drive and you will get half the capacity, right? And hence it is used for mission critical storage like accounting systems, financial data. You will see mostly RAID 10 being deployed there. And these are the advantages of RAID 1: increased read performance but reduced write performance. Okay. This is wrong. So write speed is not high, it is actually less. Okay. And fault tolerance will be there. Even if one fails, you get the entire data from the other. What is one of the disadvantages? You get only half the capacity because one is used for mirroring. Okay. And yes, RAID 1 always does not allow a hot swap of a hard disk. So if a hard disk fails, you have to bring down the system and then bring it up, replace it with a new hard disk and then coming in. Okay. Now we discuss something called as parity. Okay. Parity. Now, what exactly is parity? To explain parity, you have to understand how binary additions and subtractions work. Okay. Binary XOR calculator. Okay. In our engineering or degree, you would have learned this, right? When you have any kind of, binary like this and another one, okay, and you calculate, XOR, you will get this. Okay. You know what is the beautiful part of XOR? I'll show you. So let me open a notepad. So this was our first data block, data 1. Then this was our data 2. Okay. And once we did an XOR for both, we got this. Okay. Now let us see this. I replace this guy with this. Okay. And I say calculate XOR. What do we get? We get this. Now can we see what this is? Isn't this the same? Wow. Beautiful, isn't it? Which means once I calculate the XOR, okay, of any two or multiple, binary bits like this, even if one binary bit gets lost, as long as I have the XOR and the remaining data bits, okay, I will be able to calculate the value of what was lost. Are you getting this, girls and boys? Are you able to understand this concept of XOR? Okay. In the binary world, this is how XOR works, right? XOR is not nothing but addition, okay, in binary world. So when I add multiple binary numbers and calculate its XOR, whatever is that XOR output, okay, additional output, that and the remaining data fragments are good enough to be used to recalculate what was lost, okay. And this is exactly the same thing that happens when we calculate parity. Okay. So if you see here, what we are doing here is this data block D1 that is going on disk 1 is nothing but a bunch of ones and zeros. Whatever is going on to disk 2, okay, this data block D2, okay, that is also nothing but ones and zeros at the binary level. In order to calculate its parity P1, which is on the third disk, all I have to do is do an XOR calculation of the binary bits of D1 and binary bits of D2, and I will get what is P1. And what is the advantage of this? Anyways, P1 is a calculated value, and hence if this disk had to fail, disk 3 had to fail, okay, by using D1 and D2, I can always get P1, correct? Similarly, even if disk 1 fails and or disk 2 fails, by using the surviving two fragments, that is D1 and P1 or D2 and P1, I can recalculate what was there on the lost disk. So this is exactly called parity calculation. Parity is nothing but doing XOR of the binary bits and storing it in another place. So we understood in RAID 0 that whenever a data chunk of data is coming in, we can stripe it, right? We can stripe it. So just imagine that these two disks, disk 2 and disk 1, for just the first stripe of data, okay, first stripe only I'm talking about, that means blue, orange, white or gray, blue, orange, gray, okay, I'm talking only about the first stripe. Imagine that first stripe to be RAID 0 of disk 1 and disk 2 plus another disk holding the parity of that first stripe, and that parity is stored in disk 3 called as P1. Okay, so this is called striping with single parity. Okay, striping with single parity. Now when it comes to the stripe 2, we do not have D1 and D2 as the data stripes there. We have D3 and D4. But if you see here, these data stripes are not written again on the same disk as stripe 1. These data stripes are written on another, when it is writing on another stripe, the data is being written on different stripes and the parity is being written on another stripe. Okay, but the concept still remains the same. Okay, D3 is a set of binary values. Okay, D4 is a set of binary values, and P2, which is nothing but the parity of the second stripe on the disk, is nothing but an XOR generated out of bits in D3 and bits in D4. Okay, and then the third stripe and so on. So you can have multiple stripes in the same hard disk. Okay. Another unique thing about RAID 5, okay, if you see the placement of this parity parity portion across multiple stripes, it forms like a diagonal, right? P1, P2, P3, these gray stripes that you see, they form a diagonal like this, okay? And hence, this is also called diagonal parity, okay? Rate 5 also is called diagonal parity, okay, where the parity stripe itself is not stored dedicatedly on a single hard disk, okay. The parity itself is striped across multiple hard disks in a diagonal fashion, okay. And the advantage that you get with RAID 5 is you get the advantage of striping, because you're striping to multiple disks at the same time, but you don't need the overhead of RAID 10. That means here you are reducing almost 25% cost with respect to RAID 10. You don't need 4 disks now in order to have a single disk redundancy. Okay. You can have a single disk failed, but yet any portion of that hard disk can be rebuilt by using the remaining fragments that are there in the surviving hard disk. Okay. So this is called as a RAID 5 array, and without losing data or without losing access to data, you can build this. And that is where most of the implementations today, we will see either RAID 5 or RAID 6. Now we will come to RAID 6 a little later. Okay. But there are some disadvantages. What are those disadvantages? Yes, whenever there is a fault, it impacts the performance. Okay. Yes, read is faster than write here. Why? Because for every write, additional parity calculation or that XOR calculation has to happen in the memory of the storage controller or the server controller, okay, who is managing the hard disk, okay. And because of that, that additional calculation for every block of data or every chunk of data, okay, the writes are slower than reads, because while reading data you don't have to read parity, because the end user like us, we are not bothered about parity, right? We don't want to read parity. Parity is the internal mechanism of protecting the data in the hard disks, okay. Now we come to RAID 6. Now my first question before we going to RAID 6 is, what happens if more than one disk fails in a RAID 5 configuration? Can we still recover data? Anybody? What happens when more than one hard disk fails in a given RAID 5 configuration? Can we still recover data? Anybody? Come on. See, we saw with the XOR calculation, okay, that you need at least one data stripe and one parity to get the information back which was there on the failed drive. Okay, so at least two components are there, and minimum number of hard disks in RAID 5 is 3. Okay, so let us say in these 3 disks, 2 fail. Can I recover data? No, I can't. Everything is gone. Okay, so what started happening in the industry is, as we have understood, right, the hard disk kept getting denser and denser. Okay, and as and when the hard disk kept getting denser and denser, the failure rates also started increasing. Okay, because of high density. All right, now because of that, customers wanted additional level of protection. That was, even if 2 hard disks fail in a given RAID configuration, I still need my data to be protected. Okay, but I don't want to pay double like in RAID 10. I want 2 disk protection, but I don't want RAID 10. So that is where RAID level 6 came in, okay, where this XOR calculation that we talked about while calculating RAID 5 is done twice, not once. Okay, so two parities are calculated, okay, and both the parities are written diagonally in multiple drives so that at any given point of time, even if two hard disks fail, you still have your data intact, or you can rebuild your data which was there on the failed hard disk. Okay. Yes. Now we talk about something called as rebuild time. You see here it says there is something called as rebuild. Now, what is this rebuild? See, when a disk is failed, somebody will go and replace that failed hard disk with a working hard disk, right? So when it becomes a working hard disk, that means it's spinning, all the platters are working fine, and you can read and write to all the platters. There should be some mechanism which will read the remaining data fragments, what were originally present in that RAID before the failure of the hard disk, okay, and recalculate the data fragments that were lost in the failed hard disk, and then write those data fragments back to this new hard disk which you put inside the system, right? This entire process of reading the data fragments and parity fragments from the remaining drives, recalculating the lost data fragments in the memory, and writing those to the new hard disk, this entire three-step process is called as rebuilding. Okay, and this rebuilding takes time. It doesn't happen just like that. Because just imagine, no, in a single hard disk, you have terabytes of data. Now, doing this entire operation for terabytes of data obviously takes time. Okay. And if the RAID array or the number of disks involved in configuring that RAID 5 is large, like you have like maybe 30 disks in the RAID 5, okay, or 25 disks in the RAID 5, there are so many data fragments to be read just to rebuild one lost hard disk, right? Hence, the rebuild time also increases substantially with parity based RAID 5. Okay. But in RAID 6, some of that is taken care of. One, what is taken care of? Multiple hard disk failure. Second, the rebuild times are relatively faster than RAID 5. Okay, so you get good read performance with RAID 6, better redundancy than RAID 5. Even if two hard disk fails, okay, you can still rebuild the data. Your data is not lost, but there are some disadvantages. What are the disadvantages? Yes, the write transactions are slower than RAID 5 because you have to calculate the XOR or parity two times. Okay, and this is a little more complex technology because double diagonal parity is written. So understanding where the parity is and reading back, it takes time. And then we have RAID 10. We already understood this. Uh, to be very honest, only very small amounts of data today in the data centers, especially on servers, are on RAID 10. Okay. But on large storage systems, it is predominantly RAID 6 that happens. Okay. Yes. In a very critical server where you want performance at the same time, you do not want to lose data and you want N plus redundancy for every data drive, you will have one mirror drive, right? So you have full redundancy. Okay. And hence you get best of both worlds, very high performance and very high redundancy. But usable capacity is low and hence the cost is higher. Okay, only half is what you get to use. So yes, as a solution architect, as a data center engineer, you have to take a call. Okay, you have to tell your customer, okay, for which kind of workload and what rate to be used because of the cost implications. Okay, so generally, what we do as solution architects is very small capacity, which is required for very high performance. We will put it on RAID 10 and everything else. Okay. We will just put it on RAID 5 or RAID 6. Okay. So that's how we will design or architect the solution. And there are many rate calculators available. Every vendor who is manufacturing a storage system will have their own rate calculator. And using that rate calculator, you can easily identify what will be the usable capacity of that rate after you have implemented it, okay, in the storage system. Is this understood? The concept of rate, okay? Anybody has any doubt with respect to what exactly is rate? Actually love Wikipedia because a lot of information comes out of Wiki. A lot of information is stored here. So you see the history, and as I said, some people call it inexpensive drive, some call it independent disks, okay, but both mean the same. So you have RAID 0, RAID 1, okay. In between RAID 2 and RAID 3 had also come, but not many people used it. RAID 2, RAID 3, RAID 4, okay. RAID 5 and RAID 6 are the most prevalent, okay, in the world today. And there are combinations of RAID 10 that are available, okay. And then there are these other kinds of RAIDs, okay, that are available out there. See, what they are using is ZOR, as I showed you earlier, okay. Just they are doing zoring, which is calculating of parity by using XOR calculations, XOR additions on binary. Okay, that's what they do. There is hardware based RAID and there is software based RAID also. Okay, so which is used where? Hardware based RAID is used mostly in servers. Okay, where a specific card goes onto the motherboard of the server. It is called as a RAID controller card. Okay, so one exercise you please do today, the same server models which you had downloaded, okay, go to those specification sheets, okay, and identify what RAID controller is it supported and which RAID controller in a particular server supports what kind of RAID. Okay, all RAID controllers do not support all kinds of RAIDs. Okay, so when you are designing a solution, when you are suggesting something to a customer, you need to understand what is the RAID level that needs to be implemented on the hard disk and suggest that kind of a supported and compatible RAID controller with that particular server model in order to cater the customer requirement. Okay. When it comes to software based RAID, this is typically what is used in storage systems. Okay, so storage systems do not have a specific hardware based RAID controller. Okay, because any hardware has limitations on scalability. So a software based RAID is used in storage devices. Okay, and we will learn about this. And as you see here, in software based RAID, there are multiple, implementations that are possible, and we will look into it. In fact, when we get into our advanced course after the intermediate course, I am going to teach you exactly this one, ZFS. Okay, how to use ZFS on a storage to configure all these kinds of RAIDs. But we will learn it in the advanced course. Okay, this is what I'm going to teach you. So there are multiple different implementations, okay? But ultimately, this is used to protect data. So kindly read through this, and the learning exercise for today is go back to your spec sheets which you downloaded for the servers. Inside that spec sheet, identify the component called RAID controller. For the identified RAID controller, understand which RAID types it supports, and just see, how a RAID controller looks like, where it fits on the motherboard. Okay, so just have a uh, look into it, right, and read that carefully. Any questions on RAID? Any questions? No? Okay, okay, fine. Now we introduce a little more advanced concept, okay, which is called RPO and RTO. Now, what exactly is this? Just now we saw when we are using RAID, we can withstand hard disk failures, okay, when that failure happens inside the storage system, okay. So the most common component to fail is hard disks, okay, and hence this RAID mechanism inside a storage system or inside a server will help us to protect from that kind of failures. For every other failure in a storage system or server, there is anyway a redundant component, right? So we have two controllers. Each controller has multiple power supplies. Each disk shelf has multiple power supplies. We have seen that there are redundant connections coming from multiple controllers to multiple disk shelves. So there is n plus one redundancy for every other component that is there in the storage system, right? But what if that entire data center is gone? Okay, maybe due to an earthquake, maybe due to a fire, maybe due to tsunami, maybe due to all the internet connections getting cut there. Okay, complete power loss for multiple days. Anything can happen, right? Anything can happen. So when such a thing happens, how are we going to protect our data that was there in that data center or site to another data center or site? That exactly is what is called as disaster recovery or business continuity. And when we are talking about business continuity or disaster recovery, two most important terms that come to use are RPO and RTO. This is not your RTO of your this one, road transport authority. No, this is specific term to data center, specific term to disaster recovery and business continuity. Okay. Now, what exactly is RPO and RTO? Let me explain to you with the help of this, animation. So, first, RTO, recovery time objective. Firstly, this is always a time in the future. Okay, it is always a time in the future. So, if you consider the time at which a disaster happened in a data center as T0, okay, time 0, then your RTO is always going to be T0 plus some minutes, some hours, some days, some weeks. So it will always be a measure of time in the future. Okay, that is called recovery time objective. All right. Whereas RPO, okay, is always going to be a time in the past. Okay, so T0, if that is the time of disaster, then RPO is always referred to T0 minus certain minutes, certain hours, certain days, certain weeks, so on and so forth. Okay, now what exactly is this? RTO, as you see here, is once a disaster happens, how much time it takes for engineers like you and me to bring up the systems that are there in our disaster recovery data center or site to be completely functional, so that end users can start reading and writing to it. Okay, that is RTO. That means how much time it takes to start your operations since the time disaster has happened. So I'll give you a very lame analogy or example. Let's say you're going on the highway. Okay. When you're going on the highway, you experience a punctured tire. Okay. So the time exactly when you experience a punctured tire, that is T0. Okay. And what is RTO then? From the time T0, from the time your tire got punctured, how much time it takes for you to either call a mechanic, get that person to your car, remove the Stephanie, remove the punctured wheel, put the Stephanie in the place of the punctured wheel, put the punctured wheel back in the dicky. Okay, this entire process. Okay, and after that process complete, again you can start driving, right? Okay, so that time it took for you to replace the punctured wheel and get driving again, okay, from the time the puncture happened, that is called as RTO, and hence it will always be measured as T0 plus a few minutes, few hours, few days, few weeks, whatever. It will be referred to a time in the future. Okay. Now, but what is RPO then? RPO is how much time you would have lost. Okay. Now, if that puncture would not happen, maybe you would have reached your destination at certain amount of time. But because of the puncture, you lost time, isn't it? And hence, you will now reach your destination later. Hence, you have lost time. Okay. Now bring it to this example to your data. Okay. When the disaster has struck, okay, can the storage system accept reads and writes? No, it cannot, right? Obviously, it cannot. Then, what is your last known good copy of your data? Okay, you can recover only from there, right? So that last known good copy will always be a few minutes, few hours, few days behind than the original and the latest copy, right? It will always not be in sync. There are mechanisms to keep them always in sync, but we will talk about them later. Okay. But always your last known good copy of data will be referring to a time in the past. Okay. So if the disaster has struck at T0 at certain time, it will always be T0 minus whenever was your last known good copy of your data. Okay. So, in disaster recovery, what effectively is happening is you are recovering your data, which was as if it were a certain time in the past, but since it took time for you to recover, you are moving ahead in time, but your data is as if it was somewhere in the past. Okay, it's like a time machine. Okay, your systems are coming back online. But once the systems are coming back online after your RTO, okay, your data is not same as if it was as T0. No, your data will show as if it was T0 minus whatever is the copy of data from where you're recovering to. Okay, so this is called as RPO and RTO. Any questions? Any questions? Any doubts? No? Okay. Now I have a question for you all. What do you think is the ideal RTO and RPO when you go and ask a customer? Okay. Anybody? Okay, let me ask you this. Let us say I'm a person who is selling you a phone, okay, very advanced feature phone. And I ask you this question when you come to the sales counter that, hey dude, hey bro, uh, I have a special feature in the phone which will allow you to recover your data very quickly. Okay. So you tell me how quickly you want to recover your data and how much amount of data loss would you be okay with, okay, to go back in the time. What would be your answer? There is no right or wrong answer here, okay? There is no right or wrong answer. Your ideal answer will be, in my view, okay, Are, I want the data to be recovered instantaneously and I do not want even a single byte of data to be lost. Correct? Ideally, all of us want that only, right? Even customers also same thing. These banks, these healthcare companies, these telecom companies, everybody has the same ask. Okay, my RTO should be zero, my RPO also should be zero. That means whenever a disaster happens, all my systems in the DR side should come up just like that instantaneously, and not even a single byte of data should be lost. Okay, well, in today's world, is it technically possible? Yes, it is technically possible. Okay, and then as a solution architect, okay, or as a person who's running an IT company, I would say, sir, are you ready to pay 5 times more, okay, to achieve this? Then they take a step back. Array, it's not possible, kya? Then I said, no, sir, it is possible. Zero RTO, zero RPO is possible, definitely possible. Okay. But, sir, it's not magic, right? I cannot bend the laws of physics. Okay. I am limited by the laws of physics, right? Which means wherever is your DR site, the very first thing is I need to have an extremely fast, high bandwidth, low latency link between your site 1 and site 2. Okay. Now, obviously, for that, you'll have to pay a lot of money because it's not like broadband. You need to have dedicated fiber optic links running between these two sites. And the longer they are, okay, obviously the latency is going to be higher. It's law of physics. We can't do anything about it, right? Second thing is you'll have to spend so much on the technology where we just now learned about mirroring, right? Now we learned that mirroring is happening at the hard disk level. Now these hard disks are placed next to each other inside the same storage system or inside the same server. So it happens in milliseconds or even in nanoseconds. But when you want to achieve mirroring, that every write that is happening to site 1 should simultaneously happen to site 2, and hence zero RPO. That means whenever disaster happens, this entire site goes, each and every write is available on site 2. Then you have to spend so much on that technology also, right? It has to be extremely fast. The acknowledgement should come back to the application extremely fast. The data checks that happen before writing them permanently, they also have to happen extremely fast. Okay, which means everything should be on SSD. It should be on very high speed controllers, very high amount of RAM, very high amount of network speed. So the customer has to spend much more in implementing a zero RPO, zero RTO kind of a solution. Okay, technology is available, but people are not ready to spend that much amount of money. So that is when the customer says, if that is the case, I am okay with a 4 hour RTO and a 4 hour RPO. I said, okay, sir, great. Then you don't need such high speed. You can reduce your speed. This side also, just little bit of SSDs are enough. Everything else we put on spinning hard drives. Okay, so like that we can bring down the cost of the whole storage solution. Okay, does this make sense? Any questions? So zero RPO, zero RTO is also possible at a laptop desktop level as well as at a data center level, but you'll have to spend a lot of money in order to achieve that. Okay, and unless your data is so critical that if you lose even a single byte, it is going to result in massive amounts of financial loss or loss of life. Okay, so people will implement that kind of zero RPO, zero RTO solution only for those specific amount of data, and for the rest of the data they will have a longer RTO and a longer RPO. Okay, is this understood? Any questions? Okay, so we learned many new concepts today. Okay, we learned different rate levels. We learned what is striping, what is mirroring, what is parity, what are the different types of RAID levels. Okay, all this we learned. And we also learned how data is striped and stored parallelly, what are the advantages and disadvantages. We also learned that in servers there is an additional hardware component that allows us to implement RAID. It is called hardware based RAID, and that additional component is called as a RAID controller. So the first learning task for today is identify the RAID controllers and supported RAID types in the data sheets and spec sheets that you downloaded. So you create a tabular form, just like how you did for yesterday's class. Model number of the server, what is the RAID controller, what are the supported RAIDs? Just 3 columns. Okay. You had 3 servers, right? So server model number 1, RAID controller model, what are the supported RAIDs? Okay. Now the same server model can support multiple types of RAID. So for each types of RAID controller, you need to have one row. Okay. This is one task. Second learning task is we understood that in the storage system, software RAID is possible, right? You don't need a specific hardware to be put in the storage controller system to get RAID. Okay, it's there in the software itself. So in the spec sheets of the storage systems that you downloaded, just identify which all RAID types they support. Okay, that's it. Okay, just a list. So another table in a PDF. Okay, where row 1 would be whatever is the name and model number of your storage system, and in the next column what are the supported RAID types. That's it. Okay, very simple task. Already you have downloaded this information, so you do not have to search on the internet. Okay, just try to understand what this information means and try to relate it to what we have learned in the class today. Okay, that's all. And once you get a hang of this, it will be very easy for you to identify for which kind of workload what rate needs to be implemented or suggested. Okay, any questions, girls and boys? Anything that you felt is too complicated, difficult to understand, please let me know. Okay, if there are no questions anymore, then we'll call it a day and we'll meet again tomorrow. Thank you all for joining the class today. We'll meet tomorrow again. Thank you. Bye bye. Have a great day.